how did Intel come up with the 1103, and how did that?
Well, they followed that suggestion. How about doing separate? See, and once you had the separate select lines, you didn't need that bias generator anymore.
And according to these books, the 1103 initially didn't work. And Dave says that it would work in a chip tester, but not in the system.
Well, there were lots of issues about all sorts of semiconductor memory, not just dynamic RAMs, but shift registers and so on. These devices had relatively large input capacitances on the leads. And the other thing is, unlike logic circuits, you would have a single signal that would be driving, let's say, all the clocks. So you might have 64 chips, all with like 20 picofarad input capacitance on it. And you're trying to drive this thing with a waveform that's rising in 20 or 30 nanoseconds. So it represents a big current. And people had to do layout on circuit boards and so on to handle that kind of thing, and do bypassing of power supplies and other stuff. Until they learned how to do that, they did have some trouble. But on the other hand, I had worked with core memory back at Stanford and in a summer job, and it was not that much fun either. I mean, core memory had some real issues.
Dave, what was your experience with the 1103 as a CPU designer at Honeywell?
Well, I didn't use it there. At Microdata, we used the 6002. I came there to design the Microdata 3200, and when I got ready to ship the thing, the memory had been designed by AMS, Advanced Microsystems. We'd farmed it out to them. And I go to start testing the machine in the oven and extreme, and it didn't work. And so I spent a lot of time fixing that particular memory design, along with Jim Oliphant, who worked at AMS. So when I got hired to Intel, it was basically as the production was ramping up on the 1103. And what Intel was finding is that customers were calling up and saying, stop shipments, what's the matter? Well, our machine doesn't work. Why? Well, you can't get the memory to work. And I spent about the first 3 months at Intel flying to the airport and going to Burroughs or going to CDC or going to NCR companies, and because the 1103 memory didn't work at those companies. And the problem was always the same. I had done some early work on A to D conversion systems at Raytheon, where we're gathering data through analog data from antennas through a multiplexer, bandpass filters and a multiplexer at ADD conversion, and sticking it into core memory and then into tape memory for later processing for basically missile signatures as they went through the ionosphere. And so I'd worked with A to D and analog systems and noise issues and grounding problems and all that. So it was classic, that kind of problem. Everybody had two-layer boards because they were cheap, and nobody had adequate power distribution, and nobody had decoupling capacitors, and they were taking a single TTL, a TI 7400 driver and trying to drive all 64 chips on the card, and there were signal coupling between parallel address lines and clock lines, and basically it was simple. You just need to put a power ground plane, and you need to put high frequency decoupling capacitors in it, and you need to make sure that the chip on the far corner was operating in the same spec that was tested when it was on the tester. Many of those applications were control systems, control memories for early mainframes. There had been some of you may recall, with plated wire memories.
Yes.
So plated wire had been the big promise, and there have been a number of machines designed with plated wire memories for the control store because of its fast access. Because of the 1103 having faster access time, this was a good product. When they found out the plated wire memories didn't work, basically, they couldn't get them to work, they replaced them with 1103 memories, which didn't work either. But not because of the chip. Really, it was because of the design. So I wrote an app note, and we did some.
Well, when did you?
Then I was home.
When did you and Ted and the team get the 1103 to work and be the successful product that it was? Because it was Intel's flagship product.
It was really shipping a lot when I arrived. As I was leaving, I noticed there's an ashtray. The key, it's an ashtray that says Intel on it. But on the back, it says, in commemoration of the first $30 million quarter, January to March 1974. Now, why is that important? In 1973, Intel's revenue was $68 million. And in the first quarter of 74, they did $30 million. Because the 1103 had gone into production. I came in at the end of February because a lot of that $30 million worth of chips that went out weren't sticking because people couldn't figure out how to use them. So that was a lot of the early activity. But Intel was growing very rapidly at that point in time.
Excuse me, what was John Reed's role?
Okay, I'm sorry, there's no questions, not even for clarification.
Designing chip.
Okay, so eventually the 1103 was a success. Why was that important for Intel's improvement of their semiconductor process and foray into other areas?
Paid for it.
Well, one of the,
Yeah, so tell us about it.
one of the issues, first of all, the Silicon Gate process was a pretty new process. Some other people were working on it as well as Intel. And Intel made some inroads to help make it work much better and improve the yield of Silicon Gate. But we would talk about a learning curve. In other words, the more stuff you shove through a manufacturing line, the better you get at doing it. And you get really, it's dirt out of the process. It's dirt that affects, causes defects and reduces yield. So over a period of time, having a high volume product like the 1103 would really help you shake down the process. Then that could be used then for all sorts of other parts that were coming along. And maybe
If we hadn't had the memory product line to drive the silicon process and the volume and get the defect density down, we would never have been able to make the microprocessor.
I think that's really important.